Hey there! So, in this video, we're going to be talking about quadratic models. Now, what are quadratic models and, well, what are its characteristics? Well, one of the most more prominent characteristic is the second difference. So, hold on, let me just grab my highlighting tool. So, the second difference. So, this is important, the second difference, and you should know how to get the second difference. The graph is also a parabola. A parabola looks like, let me just get my common tools. Parabola has this sort of shape, or it could look like this. So if it's quadratic, it will look something along these two, either one of these. The equation can be written out in this type of form: y equals x squared plus b plus c, where a, b, and c are just constant values. However, a itself cannot be zero. So the quadratic must have an x term, and a must not be zero. So the best way to do this is to do some examples. So let's look at the first example. You have these points here, and if you have points, the best thing you should do is get the first difference and second difference. So these points are just rewritten down here, and you get the first difference. The first difference doesn't really matter. But the second difference, if the second difference is constant, if you here is 24 and over here is 24, which means they're both the same, which means that this is a quadratic relationship. For the second example, you can tell it's a quadratic relationship just by looking at it. The shape of it is a parabola, and yeah, that's how you can tell. You just look at the shape. That's definitely a parabola. Or you can look at the equation here. This equation here, this is a parabola, and it meets the requirements because it is in the form of x squared plus b squared plus c, because you can rearrange the equation to look like this. So, like in the every variable, if it's not shown, usually there's a 1 in front. So this is the coefficient here for a is 1, and there's an x squared. And if you put, like, you're wondering where the b squared is. Well, you put a 0 in front of the x. If you put a 0 in front of an x, or put a 0 in front of anything, it will turn that into 0. So, for example, 1 times 0 is 0, 2 times 0 is 0, 3 times 0 is 0, so on and so forth. So anything that multiplied by 0 is 0. That's why you don't see that in this equation here. But you can rewrite it, you can put it here. And then this 7 is that 7 there. Okay, so here's another example. This is a fountain of sparks from Canada's Day's rocket follows the arc in the air. The table shows the height of the sparks at various horizontal distances from the launch point. So distance will be your x variable because it's independent. Distance always remains the same, but the height changes depending on the distance. Now I went to Desmos, and I put that into Desmos, and I got this curve here when you graph it. And another thing that's great about Desmos, let me show you. Another thing, so I put in Desmos here, and you can see that. Let me just zoom in. Here's the points. And the great thing about Desmos, if you put this equation and you need this squiggly line, the squiggly line represents, you can't put an equal sign. This symbol is actually called tilde. So put this tilde symbol here, and you find it on the top left corner of your keyboard. And if you drop this equation, and remember, up here is x1 and y1. So down here, you have to use y1 and x1 right here, x1 here and x1 here, for you to relate to this table. So you put that in there, you'll get this curve of best fit. And what's great about this is that you see here these parameters, it actually gives you the parameters. It gives you the A, gives you the B, and gives you the C. So you can actually make an equation. And based on this equation, what you could do is you could make predictions anywhere. Like what would it be here? What would the height be here? What would the height be here? What would the height be here? And anywhere. And the thing is that's the whole point of having an equation, so you can make predictions in the future. So if you want to know what the height is down over here when it's 0, all you have to put is put x, because x represents the distance, and the horizontal is the distance. So you have to put 0 for all the x's, and you will find out what the height is here. It should be 0 though. And yeah, so let's go back to our page here, and yeah, that's the end of the notes. Okay.